if you're having difficulty in seeing this, you can switch this presentation to full screen, then you can switch it back by unchecking the full screen option. If that helps a little bit more, please feel free to do so. Now, this small application, this proof of concept application implemented in Adobe Flex, demonstrates the widgets that we have developed. And you can see the medication list here. When I say get medications, it is going to get a random set of medications from a DMD database. I'll go into details of that backing service in a couple of minutes. But for the moment, I would like to show you this widget. For example, this is a completely custom developed from scratch type of component, and this particular cell in this table layout is an implementation of the medication line. Now, it doesn't provide a lot of information, you may have noticed, and that is because the information that we are getting for this widget is coming from only the DMD database. But in order to get all the information that you would like to put into this particular cell, you would have to have access to a clinical system and to a prescription management system, etc. This is where I would like to remind you that the technical and clinical community is absolutely vital for our project, because by having that, we may be able to provide more data into this implementation, connect it to more systems, therefore test the specification better. Now, I would like to show you why text processing is important. I hope you'll be able to see this, but for example, the line breaking logic is described in great detail in medication line specification, that subset of CURIO, where you're not supposed to break, for example, a dose statement. Here you can see it's dose 5.0. So if you use normal word wrapping, the natural response from a layout engine would be to break 5.0 and put it in the next line, for example. And CURIO specifies that for patient safety purposes, that's not the right thing to do. So the component manually has to track the position of pretty much single characters and layout accordingly. For example, if I just make this a little bit narrower, you'll see that instead of breaking those 5.0 into 2 lines, it takes the whole dose statement to the next line. This is the kind of functionality you end up implementing, and this is why you end up using text processing, text metric functionality in the underlying framework. Now, again, this and it has to be very precise. Just to give you an example, I'll make this large again. Here you can see in the third line, for example, just it is barely fitting. So I have to have pixel level precision. Okay, I'll just swallow the 0 at the end of the line. Okay, at this point, when I resize it, the component needs to know that there is only a single character that is now being left out because of the width, the new width of the column. And these are the kind of things the implementers need to tackle, trying to deliver the implementation for better patient safety. Another feature, for example, of this widget, I hope you can see it. There's a look ahead bar just here. It will become more visible in a second. Let's just scroll this a little bit. Okay, if you take a look at the name of this medication, of this drug here, you can see that it is just at the top of this row. It's just about to be partially invisible, for example. And another click means a 5-pixel scroll for this particular setup. And now you can see the name appearing in the look ahead scroll bar. Now, these are the kind of challenging implementations, but they are necessary because, you know, if you take a look at the CURIO specification, you will see that because of patient safety issues, if a medication is partially visible, it needs to be displayed in the look ahead bar so that the clinician shouldn't miss any information. But at this point, I think it's necessary for me to say that the CURIO team is continuously working on the feedback that they're getting from us and from other vendors, so that they are updating the specification so that some of the technically challenging tasks are not required to implement the specification. So at the moment, the specification that we use for this project is a little bit old. I believe the new version, you know, the existing version, the current version that Tim and his team is working on is better refined when it comes to these kind of technical challenges. So, you know, the other things that you can do in this widget in compliance with the CURIO specification, for example, if we group the components based on the prescriber, you will see that this doesn't really make sense, the names of the prescribers, because they are randomly generated, just like the medications, but still, it allows us to experiment with functionality like collapsing, expanding groups of medications. And this is all a custom component. A good example of what I've said before is, for example, you may have a grid component in a framework, but it's not going to support necessarily grouping, or if it supports grouping, it may not necessarily allow you to put a label just next to the grouping collapsing button. So you start with an existing grid, and then you reach another specification item that forces you to develop some custom solutions. So in general, custom component development and an appropriate framework for that becomes a real requirement. So just to give you some more functionality, just to show you a little bit more of the functionality. For example, if I say, instead of the current medication, just show me the ones in the past 1 year, you'll see that it is going to filter the medication, and you can go back to the current medication again. These are the major important technical challenges that we try to tackle by implementation, and we are hoping that it is going to be a base for implementing more. Now, another widget, for example, is a quite powerful one, is a drug administration chart. By the way, I think I'm spending a little bit too much time on describing the widgets, so I'll try to speed up a little bit. For example, this is an implementation of the drug administration chart, again, trying to stay in compliance with the CURIO specification. You can see that, as you know, it is still getting random data, but it is successfully providing examples of UI functionality. Like, you should be seeing a pop-up now providing a bit of information that will be critical for this administration. And if you click on it, for example, you would see an administration form where you should be able to enter information. Of course, most of the functionality here is not supported by an actual proper clinical system. So it really doesn't make sense if you're a clinician. What we're hoping is that as we start building a community around open source implementations, we'll be able to connect this to actual systems and get better, more sensible demonstrations and provide better feedback. This particular widget, as you can see, also provides similar functionality like grouping, collapsing groups, and navigating between dates, and providing, for example, a short overview of the due and overdue drugs. It is sensible to time. It displays a time scale that is proportional to to the actual events. For example, I'll get some more random data. Hopefully some significant drug administrations. Yep, here you go. For example, when I say the time scale is proportional, I mean, for example, if you're talking about a significant drug administration from 4 o'clock to 11 o'clock, this is randomly generated, so it doesn't necessarily make sense. You'll see that the height of this widget, this component, covers a proportional amount of space given the whole day. So most of the functionality here, you can find it in the CURIO specification, but this is just an implementation of all the key technical challenges so that it will be easier for everyone to follow us. Now, I need to check with the slides just to make sure that I'm not missing anything here. And the final widget that I want to demonstrate is quite an interesting one. It is the single concept matching. But single concept matching widget is actually very simple in the UI, but quite complex in the backend because it is performing text-based queries on a SNOMED CT service using a SNOMED CT implementation in a terminology server. Now, this is where it gets interesting because it is related to non-UI work, which I'll summarize in a while. What you need to do, for example, to power something like a SNOMED CT search and select widget is to connect that to a host system which will provide functionality. Likewise, the medication that you've seen that was randomly pulled from our open source mockup server implementation is coming from the DMG file that is released by NHS. So as you can see, in order to feed the user interface, we had to do a significant amount of work in the backend. But the good news is you probably have systems which provide this functionality already. And if you do not have this kind of functionality, well, we have developed, especially for terminology, a quite good setup that would make it easier for you to test this. Now, when it comes to non-UI work, for example, for DMD, we have produced this tool that you can use. It takes the XML file from NHS, loads it up to a database, then allows this database to be exposed via web services to the user interface. And all of this is done using open source software. And all of this is done using open source software which do not have any licensing issues. We've been very careful about choosing open source but non-viral licensed open source frameworks. Another important thing which I mentioned is the SNOMED CT integration. I'm quite sure some of you at least is familiar with the challenges of SNOMED CT implementation. In this project, in order to implement the single concept matching widget, we needed a SNOMED CT implementation. It's not something that you can easily fake. I mean, the simplest thing that comes into mind is to get the SNOMED CT release files, put them in a database, and just connect a web service to connect that to the actual user interface. But we wanted to do better than that. So we used LexEVS, a full-featured open source terminology server from NCI, National Cancer Institute of the United States of America, and we connected that to the widget implementation, which provided us a lot of flexibility and a lot of testing opportunities to see how it behaves. Just to give you a simple example, for example, I am now going to perform a search in the SNOMED CT subset which is the DMD subset released by NHS by using a keyword like